Hi guys. In this video, I wanna show you what is a accumulation function. Let me show you how this function is defined. Here we have a graph of a function y equals f of t. Now, the graph and there is a region. It is bounded by the graph of the function y equals f of t, and it bounded by this horizontal axis, the t axis, and it bounded by this number t equals a, and bounded by this variable. Now remember here, x is not a number, it's not a fixed number. X is a variable. So in the previous lecture, we know that the area of this bounded region, we can use a definite integral to represent. So that integral is from a to this variable f of t. Now here, since the input variable is t, so when I write the integral here, I write as a dt. So this will be the result of this, gonna give me the area of this region. Because now this answer is not a number. Why? Because the x is changing. So therefore I call that as a function, and this is the accumulation function. So the function value, we can say that the function value depends on the x. In this case, if we increase the x, then of course the function value will increase as well. Why? Because when we increase the x, let's see, when we increase the x, then we can get more area. We can get more area bounded, right? So that's why the value of the function will increase. So that this means the accumulation function is always an increasing function. No, that's not always true. If we look at this example, so the function is defined by using this graph, y equals f of t. The graph looks like this, and the function is defined by using this integral from 0 to x f of t dt. So at the beginning, when we increase the value of x, we will get some negative area, because this region is below the horizontal axis, is below the t-axis. So in the process of increasing the value of x, we get some negative area. So you can see the function value at the beginning, when x is 0, this equals 0, right? But when I start increasing the value of x, it becomes negative and becomes more negative as I move this to the right. Okay, now once I pass this point, once x past this point 1, we start getting the positive areas. So the function value, you can say, start getting bigger, start increasing and increasing and increasing. And now once it passed this point, since the graph f of t, it goes down, so we'll start getting negative areas. So the function value will start decreasing again. Okay, so we cannot say that the accumulation function is always an increasing function or a decreasing function. The function value, it depends on the graph of the function f of t. Okay, now in this case, since f of t is always above the horizontal axis, so we always as we increase x, we always have a positive area add up. So in this case, the function is an increasing function. But if the graph of f of t is below the horizontal axis, then the function will be a decreasing function because we will have more negative areas added up. Okay. So the definition of the accumulation function is written by using a definite integral from a, which is a fixed number, to x, which is the variable f of t. So the difference between a definite integral and a accumulation function is the result of a definite integral is a number, is the area of the boundary region. Let's say if I change this x into a number into b, so the result will be the area of this boundary region. But for the accumulation function, the result is a function a of x, and the function value, it depends on the x. Okay. So it's a net area bounded by the graph y equals fx and the x-axis, and bounded by the two fixed points x equals a and x equals b. And for the accumulation function, the result is a net area bounded by the graph of y equals f of t and the t-axis, and between the fixed point t equals a and the variable t equals x. Okay. Let's see. We'll look at another example. Okay. In this program, the blue line is the graph of the function y equals f of t. Here it uses the variable k. But this is the f of t in our node. Okay, and so as I increase the value of x, so I always get a positive areas add up, right? So, and this curve is the graph of the accumulation function. So you can see as I increase the x, the function value is increasing, right? So in this case, the accumulation function is an increasing function. Why? Because f of t, the graph of f of t is always above the t-axis. Okay. So let's look at this example. We are given the graph of function y equals f of t. It looks like this. Okay, and we define two accumulation functions. One is ax equals the integral from -2 to x f of t dt. And the second function is the integral from 1 to x f of t dt. We want to find the following. Okay, so first, what is the function value a of 1 and g of 1? So a of 1 equals, to find a of 1, we substitute 1 for x. So in this integral, we replace x by 1. That is for negative 2 to 1 f of t dt. And next, we need to know what is the net area represented by this definite integral. So for negative 2 to 1, the net area equals phi. So the answer is phi. Okay. And for g of 1 equals the integral from 1 to 1 ft dt. Now, in the previous video, we said if the lower bound and the upper bound are equal, then the integral equals 0. So g of 1 equals 0. Let's see. A of 4. So A of 4 equals for negative 2 to 4 ft dt. The net area of this integral, so from negative 2 to 4, so the net area is phi minus 10. So that equals phi minus 10, which is negative phi. And g of 4 is equal to the integral from 1 to 4 ft dt. So that net area, so from 1 to 4, that net area equals negative 10. And A of 7 is the integral from negative 2 to 7 ft dt. So it is 5 plus 2. The area of this piece is 2 and minus 10. Okay. 5 plus 2 minus 10. That is negative 3. And the g of 7 equals the integral from 1 to 7 ft dt, which is 2 minus 10. So it's negative 8.